Far beyond the familiar planets and the icy expanse of the Kuiper Belt lies a realm of profound mystery, the Oort Cloud. This vast spherical shell of icy bodies is thought to encircle our solar system, marking the outermost reaches of the sun's gravitational domain. Unlike the inner solar system, where sunlight bathes planets in warmth, the Oort Cloud exists in perpetual darkness and frigid temperatures. It is a cosmic deep freeze, harboring remnants from the earliest days of our solar system's formation. The Oort Cloud is still a theoretical concept, its existence inferred from the trajectories of long-period comets that streak through our inner solar system. These icy wanderers, hailing from the distant Oort Cloud, provide tantalizing clues about this enigmatic region billions of kilometers away. Yet, despite its vastness and potential scientific significance, the Oort Cloud remains shrouded in mystery. Our understanding is built on a foundation of theoretical models and the occasional glimpses provided by long-period comets. Imagine a giant sphere enveloping our solar system, a cosmic bubble so vast that it dwarfs the orbits of all 8 planets combined. This is the Oort Cloud, a hypothesized halo of icy objects that stretches out to an estimated 100,000 astronomical units from the Sun. To put that into perspective, 1 astronomical unit is the average distance between the Earth and the Sun. The Oort Cloud is believed to be populated by trillions, perhaps even quadrillions of icy bodies. These are not like the rocky asteroids we find in the asteroid belt between Mars and Jupiter. Instead, they are composed primarily of ices, frozen water, methane, ammonia, and other volatile compounds. These icy remnants are thought to be leftover building blocks from the early solar system, cast out to these distant reaches by the gravitational interactions of the giant planets. Unlike the relatively flat plane of the planet's orbits, the Oort Cloud is thought to be spherical, surrounding the Sun in all directions. This spherical distribution suggests that the objects in the Oort Cloud were not formed in their current locations. Gravitational interactions with the giant planets, particularly Jupiter and Saturn, then flung these icy bodies outward, scattering them into the distant random orbits that characterize the Oort Cloud. Every now and then, a celestial visitor graces our skies, streaking across the night with a luminous tail that inspires awe and wonder. These are comets, icy remnants from the solar system's formation, and some of them, the long-period comets, are thought to originate from the distant Oort Cloud. Unlike their shorter-period counterparts, which hail from the Kuiper Belt beyond Neptune, long-period comets have orbital periods exceeding 200 years. Some of them take thousands, even millions of years to complete a single orbit around the Sun. As these icy wanderers journey from the frigid depths of the Oort Cloud towards the Sun, the increasing warmth causes the ices on their surfaces to sublimate, transitioning directly from solid to gas. This process forms the characteristic coma, a hazy cloud surrounding the comet's nucleus, and the iconic tail, which can stretch for millions of kilometers. Each long-period comet that graces our skies is like a messenger from the deep freeze, carrying within its icy nucleus a record of the conditions that existed in the early solar system. The Oort Cloud, though distant and sparsely populated, plays a crucial role in defining the very boundaries of our solar system. It marks the outer limits of the Sun's gravitational dominance, a region where the Sun's gravity, though weakened by distance, still holds sway over the celestial objects within its reach. Imagine the Sun's gravitational influence as a vast invisible web, extending outwards in all directions. The planets, asteroids, and comets within our solar system all reside within this web, their movements governed by the Sun's gravitational pull. The Oort Cloud, situated at the fringes of this gravitational web, represents the outermost region where the Sun's gravity still exerts a significant influence. Objects within the Oort Cloud, though loosely bound, are still considered part of our solar system because they orbit the Sun. Beyond the Oort Cloud lies interstellar space, a realm where the gravitational influence of other stars begins to dominate. It's a boundary marked not by a physical barrier but by a shift in gravitational allegiance. The Oort Cloud, due to its vastness and the relatively weak gravitational forces at play, is susceptible to perturbations from passing stars and other galactic objects. Despite its hypothesized vastness and its crucial role in our understanding of the solar system, the Oort Cloud remains frustratingly elusive. Detecting individual objects within this distant, sparsely populated region is like trying to find a cosmic needle in a haystack, a challenge that pushes the limits of our current observational capabilities. The primary obstacle lies in the Oort Cloud's immense distance from Earth. At trillions of kilometers away, even the largest Oort Cloud objects appear incredibly faint, their reflected sunlight a mere whisper against the backdrop of the cosmos. Adding to the challenge is the inherent darkness of these icy bodies. Unlike stars, which generate their own light, Oort Cloud objects only reflect sunlight, making them incredibly faint and difficult to discern from the surrounding darkness. Despite these obstacles, astronomers are not deterred. They are developing new technologies and observational techniques, including larger telescopes with more sensitive instruments, to try and overcome these challenges. The Oort Cloud, though situated at the fringes of our solar system, is not immune to the gravitational influences of the wider galaxy. In fact, it is thought to be a dynamic region, constantly being shaped and reshaped by the gravitational tugs of passing stars, rogue planets, and even the Milky Way's galactic tides. Imagine a rogue planet, perhaps ejected from its own star system, drifting through interstellar space. As it passes through the Oort Cloud, its gravity can stir up the icy inhabitants, nudging some into new orbits, perhaps even sending them plunging towards the inner solar system as long-period comets. Similarly, encounters with nearby stars, though relatively rare, can also have a profound impact on the Oort Cloud. The gravitational pull of a passing star can create ripples of disturbance, jostling Oort Cloud objects and scattering them like billiard balls on a cosmic table. Even the Milky Way's galactic tides, the gentle gravitational forces exerted by the overall distribution of matter in our galaxy, can influence the Oort Cloud. These tides can stretch and squeeze the Oort Cloud, potentially dislodging objects and sending them on new trajectories. These gravitational interactions make the Oort Cloud a dynamic and ever-changing region. The Oort Cloud, despite its distance and the challenges in observing it directly, holds immense scientific value. This vast icy realm is a treasure trove of information about the early solar system, preserving remnants from the era of planet formation in a pristine, deep-frozen state. The icy bodies within the Oort Cloud are thought to be leftover building blocks from the protoplanetary disk, the swirling cloud of gas and dust that surrounded the young sun billions of years ago. These icy planetesimals, scattered outward by the gravitational interactions of the giant planets, carry within them a record of the chemical composition and physical conditions that existed during the solar system's infancy. By studying the composition of long-period comets, which are thought to originate from the Oort Cloud, scientists can gain insights into the chemical makeup of the protoplanetary disk. Analyzing the ratios of different isotopes, for example, can provide clues about the temperatures and pressures present during the solar system's formation. Understanding the Oort Cloud, therefore, is crucial for piecing together the history of our solar system. Imagine our solar system as a vast cosmic ocean. The Sun, our life-giving star, sits at the center, its warmth and light diminishing with distance. The inner planets, rocky and close-knit, are like islands basking in the Sun's radiance. Beyond them, the gas giants, Jupiter and Saturn, stand as colossal sentinels, their gravitational influence shaping the solar system's structure. Further out, beyond the orbit of Neptune, the Kuiper Belt, a ring of icy bodies, marks the beginning of the solar system's outer reaches. But it is the Oort Cloud, that vast spherical shell of icy objects, that truly defines the shores of our solar system's cosmic ocean. Like the shoreline of a terrestrial ocean, the Oort Cloud is a region of transition. It marks the boundary between the Sun's gravitational domain and the vast expanse of interstellar space, where the gravitational influence of other stars begins to hold sway. The Oort Cloud, however, is not a static shoreline. It is a dynamic and ever-changing region, constantly being shaped and reshaped by the gravitational tides of the Milky Way and the occasional passing star. The Oort Cloud, a distant realm of ice and mystery, beckons us to explore the outermost reaches of our solar system and beyond. It is a reminder of the vastness and wonder of the cosmos, a testament to the enduring power of gravity, and a source of endless fascination for astronomers and dreamers alike. Though shrouded in mystery, the Oort Cloud holds tantalizing clues about the formation of our solar system, the dynamic interactions between stars and their galactic environment, and perhaps even the origins of life itself. Each long-period comet that graces our skies is like a message from this distant realm, carrying within its icy nucleus a record of the conditions that existed billions of years ago. As we develop new technologies and observational techniques, we inch closer to unraveling the secrets of the Oort Cloud. Each new discovery, every piece of data gathered expands our understanding of our place in the cosmos, revealing a universe far more complex and interconnected than we could have ever imagined. The Oort Cloud, a distant echo of our solar system's birth, reminds us that our journey of discovery is far from over.